I recently saw a simple AI research agent built in n8n with Perplexity. Then I thought if I could build something similar using free models only. So let's jump into the main stuff. The workflow mainly consists of 5 parts, which are workflow start, then comes first phase of the research, which is surface level research. Then comes second phase of the research, which is replicating deep research. Then we have aggregation and creating final output phase. And finally, workflow end. So the workflow starts with manual trigger. Then we have Google Sheets node, which we use to take user questions from Google Sheets. By the way, I have configured this Google Sheets node in a way where it only takes questions with an empty research report cell. Then we have a loop here. Each question goes into this loop to later enter the first phase of the research. First phase consists of 4 main nodes. First, AI agent node breaks down main user question into sub-questions, like the question it first gets is this, then breaks it down into sub-questions like this. And it has the system message like this one. And plus, we give user question as a user message here. Then we have a code node that comes right after this AI node. What it mainly does is like this. The AI node sends the output as one main JSON array, and this code node takes that output and splits all its content into separate different questions that we can use for research. And code itself looks like this. Once the questions are ready, they go into our next node, which is search tool. Tavily Search tool. I have used Tavily Search tool for this research workflow, and I had added it like community notes section. By the way, it has an update. I will do it later. And for its API, you go to their website, you log in. After sign up, you will see a dashboard like this, and API keys section like this. You just copy it here, and go to your n8n. Click on create new credential, and here you just add your API here and save. You will see a green credential successful message and save. Finally, the last node in the first phase is this context compressor AI agent. What it roughly does is it takes the output coming from Tavily tool and turns it into a final polished version, and system message for this AI agent is like this. Now let's jump into the second phase of the research, where we replicate the deep research. In this phase, a Critic AI agent node comes first. What it roughly does is that it takes a look at the output of the first phase of the research, and it finds the gaps in the output. Then its system message is something like this. Then, of course, we give first phase's output as user message to it. After it finds the gaps, we again use a code node just like the one we used before, and again the code node looks like this. Next we have next Tavily Search tool, which searches for the extra questions. And again, this AI node also does the same as the previous one. Its system message is like this, and we give it this query as user message again. Now we are in the last step that comes just before the final one. What we do here is taking the outputs from both phase 1 and phase 2 and aggregate their outputs, then merge them here together just to send it to the final AI node, which integrates those both outputs just to create one final comprehensive research report. Now, if we take a look at the first aggregator, I have renamed the output like this, that comes from phase 1, like research summary light, and the other aggregator like I have named also like Research Summary Deep. Then in the merge node, I'm combining the input like according to their position. It positions them, both of them, Research Summary Light and Summary Deep, one after another. Our next node, AI Integrator, takes this data coming from merger node and integrates both Research Deep and Light to be one final comprehensive research report. After that, oh, by the way, let me show you both user message and system message of this integrator node, like so. One more thing I want to show you here is this toggle. The main reason for toggling this, because sometimes you can be one of many who use this AI model at the same time, and Gemini rejects your request. In such cases, you toggle this option on, this parameter on, and set max tries to 3 and wait time to 5 seconds. Most of the times it succeeds. That's why I didn't need to toggle this on to enable fallback model parameter. Next, we go to the final chapter of the workflow. After research completely finishes, it comes to this edit fields node. With this node, I'm adding user questions to the final report, final output. Then I jump onto the next Google Sheets node. What it does is appending final research report to the same Google Sheets document where we took user questions from. And I have selected question column as a column to match on. By the way, there's one more thing I need to mention. The main reason why I added edit fields node just before this one was because this Google Sheets node could not see all of the questions. It only saw the first one. So I added edit fields node to add all of the questions dynamically to the final report, just to make sure this append node sees all the questions dynamically, and then match the question to the report or report to the question. So that's it. This Sheets node appends each report to its corresponding question, like here and here. So lastly, there are a couple of things I want to mention about this whole workflow. First of them is this loop node, which was here in the second phase of the research, together with Tavily node. During describing the workflow, I realized that we don't need this loop, since Tavily node searches for each question on its own, one by one. Then I removed this loop node, but forgot to mention it. So we are deleting this. Then the second is these two wait nodes. I used them mainly for not having rate limits for AI models. One is wait 12 seconds, the other is 5 seconds, because it's best to make it close to 1 minute on each cycle for each AI model as possible. And lastly, I've used different AI models from different providers like Grok, OpenRouter, and API from Google AI Studio. So the first one that splits main question into sub-questions is Llama 3.37B versatile model. The second one is for first context compressor, Kimi K2 instruct model. The third one is from OpenRouter and NVIDIA's Nemotron 3 Nano. Fourth one is again the same model from NVIDIA. And the last one, Gemini's 2.5 Flash. So that's it. That was all I wanted to talk about. See you on the next one.